Hi, in this video we will solve problem house robber asked by companies like Amazon, Microsoft and Facebook. Now let's solve one more problem on DP series, right? So we have the second most important problem, house robber. Okay. Why I'm saying second most? Because if in any interview you will get problems like number of waves, find the number of maximum path or any path that is at maximum, right? So you can solve all that type of problems by doing climbing stairs. But now like you will see these types of problem in most of the interviews, right? House robber and some other versions of house robber, right? So let's quickly check this problem. Then you will get to know that you have already solved this problem in somehow. And when we were doing with learning with arrays and multiplication, implementation, all these things. Okay. So let's see. So we have house robber. You are a professional robber planning to rob a house along a street. So each house has certain amount of money. Okay. So these are money. Okay. The only constraint stopping you from robbing each of them is that adjacent houses have security system. So adjacent house have security system connected and it will automatically contact the police if two adjacent houses were broken into the same night. So basically you can rob this one but you can't rob this one, right? Then you can rob this one but you can't rob this one, right? You can't rob the adjacent, right? If you are planning to rob suppose this one, right? So you can't rob this one or this one, right? You need to rob the next one or next to next one. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight. So basically you need to find out by doing this way the maximum amount that you can rob, right? So suppose if I'm taking starting from here 1, right? So I will simply rob 1 and then I can't take 2 and I will jump to the next one and here I'm getting 3. So after this 3 I can't rob this one, right? And there is no other element after it. That's the last element. So the robbing I have done, I am getting a money of 4 unit. Okay. If I am taking a second case, suppose I'm starting with 2, right? And the only thing, the next robbery I can do only on this house. So I'm getting a maximum of 3 by this approach. And what is the maximum, right? 4 or 3, like from these one try was this one, second try was this one, and here I am getting the maximum amount of money. Okay, so the 4 will be the answer. Similarly, if you can check this one, right? We have 2, then after 2 I will rob 9 because that is has maximum value, and then I will rob 1. So what will the total value I will get? 10 and 12, right? So that's why the output is 12. If you go, if you want to choose other path, you are starting with 7 and you are taking 3. So the max to max you can achieve that is 10, but that will be wrong. So the correct answer will be 12. Now let's see how we can solve this problem, right? So let's try it. So let me quickly create an array. Now let's see how we can solve this problem, right? So we will discuss various approaches, okay? Let's see how we can come up with few approaches, right? So think on this way that you can choose this one, right? You are starting from this one. Suppose the first one you are taking this step, right? You are taking this one and the next will be only this one, right? You have this option. But see, right here as well, the number can be higher, right? Suppose here can be 4, right? So what you will do? Will you take this one, right? From here, suppose from here, will you take this one? Will this be a good option? Like 1, then jump to the next. Will it be 4? I guess no. If you start from here, right, and then you are taking 4, then it will be a best option because here you are getting 6, right? And similarly, suppose there is one more element right here, 5, or suppose let's take a huge element, 10. So choosing this one will be good, right? Suppose you are starting from 2 and you are choosing 4. Will this be an option good? No, absolutely not. Now you will take 1 and then 3 and then 10, then it will be good. So basically you don't know, right, what can be the next element can be the greater. Okay, or by taking which value I will get the best result, right? You don't know. So what you will do, you will leave these things to the recursion, right? It will solve that problem. What you need to do, you just need to figure out that somehow I will take the best of these two, right? I will take the best of these two, right? So basically I will take the maximum of 1 and 2, right? And how I will decide from this one? Basically, I will take this one 1 and I will say maximum of maximum of that is 3 and 4. Okay. So basically you are saying you will start from 1 and you will take the maximum of 3 and 4, whichever it is. S- So by this result, you will get 1 plus maximum of 3 and 4 will be 4. You will get 5 as a result. Right? So this was when you start from 1. Suppose you called this one also 2. So if you are starting from 2, what you will do? You will say 2 plus maximum of next 2, right? So you are getting here 4 and there is nothing in the next, right? So let's assume 0, right? And what will be the result? The result will be max will be 4, it will be 2, 2 plus 4, then it will be 6. And what you will do, I said you will return the maximum of it. So by this path, by choosing this path, you will get 5 as a maximum. By choosing this path, you are getting 6 as a maximum, right? So what you will do, you will return the maximum of these two and you will return 6. Clear? Clear? Let's see, let's understand this by some more examples. So this will create a bigger picture. Again, let's see. Right? So I have this value. Okay, let me remove this one. Then here, I'm giving you the idea. Let's see this one first. So we have this one. Again, what I'm saying, okay, I will take the maximum of, okay, now instead of calling this one that maximum values, I will say my answer will be method.max of the two if I start from this one or if I start from this one, right? So what I will do, I will say, suppose this, I will call my robbing function, right? Rob function, I will pass the nums, that is my array. Okay, I will pass this nums and I will start from 0, right? So this will start from here and I will pass in the next one, I will pass nums and that will start from 1, right? So this will be my result. I will take the maximum of it. Now, once I am starting the robbing here, what I am saying, my rob function basically, if I have a robs nums of I, what it will give me? It will basically return the nums of I, that is 2, okay, plus it will return the maximum of next 2. So if I'm starting from this, where I should jump? I should jump between the maximum of these two, right? So whichever it will be the maximum. How I will get to know that which is maximum? Again by calling the same function. So what I will do, I will again call method.max, okay, and same I will call, let me put it here. I will call method.max with rob nums and I will call I plus 2. This is one. And the second will be rob nums I plus 3. Right? My nums of I will be best of these two. Right? So basically what it will return, let's execute this function. Okay. So basically you called rob nums of 0. So yes, you started with 0. And what is this function? That is nums of I. That means 2 plus met.max of rob of I plus 2 and I plus 3. Right? So first I will execute I plus 2. What it will be I. So here I am calling this function. Let's always remember that what is the value here? I plus 2. That means 0 plus 2. So you are calling with an index of 2. Remember. Okay. So I am putting nums here. You are calling this. It basically returns the max of. So let me put it like this. It will basically return the max of rob nums 2, right? And then next function call, but that is not called. I am solving this function. So I will solve this function first. What is this function nums of 2? Basically again nums of I, that means 2 plus, sorry, nums of I, that means 9 plus, again one function call, the best of these two, but here we are not getting any result, right? Like there is no nums of I plus. If I say I plus 3, that means I is 2, 2 plus 3 will be 5, but there is nothing in the 5. So can this be my base condition? If my I is getting greater than equals to n, right, I will simply return 0. So yes, I will return 0, right, in this function call. So I will first call this function and I will say I will find max of rob, that is nums, and I plus 2, that will be 2 plus 2, 4. Okay, so now first execute this function, right? First execute this function. Once this is completed, then I will call the next function. So what is this nums of 4? It will basically take this value and it will call the max of next function. So max of next function will be nums, rob nums, and 4 plus 2, 6, right? But this will give you 0 result because I is greater than equals to n. So can I say this will give you 0, right? And the next function call will be I plus 3. So 4 plus 3 will be 7. That too will give you 0, right? So we will call the next function with the rob nums 4 plus 3, that will be 7. And this will also, because I is greater than equals to n, this will also give you 0, right? So both the values are 0 plus 0 and 0. So the result will be 1. You will return 1 to it. Okay. So now the value of this one is 1. But we need to call the next function, right? Remember. So next function will be rob 2 plus 2 was 4. 2 plus 3. This 2 plus 3. So it will be rob nums 2 plus 3 will be 5. Okay. And can I say I is greater than equals to n? Because we don't have 5. So this will also give you 0. Right? So now what is the maximum of 1 minus 0? That is 1. So can I say this result will be 10? 9 plus 1, 10. I will return 10 to it. Okay. And it will call the next function now. So what is the next function? That is rob. Okay. 0 called it. Basically you called it 0. That is 0 plus 2. Then it will be rob 3. So it will be rob nums of 3. Right. What is nums of 3? So nums of 3 will be, again I will execute in the same way, right? It will first calculate 3 plus it will call the next function, and both the next function are outside of it, right? I plus 2 and I plus 4. 3 plus 2 will be 5 and 3 plus 3 will be 6. So can I say I will get the result there 0 only, right? So from here I am getting 3, from here I am getting 10. So 10 and 3, which is maximum? 10. So I will take 10 and then will be with the 2, it will give me 12 and 12 will be my answer, right? So this is how I am calculating, but that's the answer for this one that I started with rob 0. The same thing I will do with the rob nums of 1. So what I will do, I will do the same exact thing, right? Exact same thing. I will start from 7 and I will call that function, right? I will start that function. So I will take 7, right? Suppose I am taking 7 and then again I will call max of next 2, right? Either this one or this one. So from these two, what I will get, right here I will get 3 only, right? 3 and the next will be suppose 1 plus 0. So I am taking 3 comma 1. 3 comma 1 will give me 3. So here 7 plus 3 give me 10. So now from 12, this is the 12 result, this is the 10 result, and I will get 12 as an answer, and the final answer will be 12, right? I hope you got it, this approach one, right? I guess that's a bit of approach one. It's more like on recursion, right? Okay. But so we will do enough dry run to understand it much more better. So don't worry about these things if it is not clear at the first. The only thing that I want to mention here that we are calling these functions, and again there will be a possibility that same function calling twice. So what I will do, I will again store a DP here. So I will store dp again, that is this will be my dp of I, and I will return dp of I, right? And somehow in any condition, if I am getting my dp of I is already defined, right, is present, what I will do, I will return the dp of I, right? This thing we will do. So this will be one approach. Now let's see the second approach. What will be the second approach? Again, the same, we will do recursion, but a bit of different sense. So if you remember that generating subsequences, how we generate basically subsequences, right? So if there is A, B, C, I have a string of 3, how I will generate a subsequences? So I will start with an empty string and I will take a call of take it or not take it, right? So I have 3 calls. Either I can take A or I can take B, C, right? So first call of A, if you are taking it or not taking it. So if I am taking it A, it will be A. Okay, let me make it a bit here. If I'm taking A, it will be A. If you are not taking it, it will be an empty, right? Then the next call will be for B. If you are taking B, it will be AB. If you are not taking B, it will be A only, right? The next call will be for C. If you are taking it, it will be ABC. If you are not taking it, it will be AB only. Similarly, for this A also C call. If you are taking C, it will be C. If you are not taking it, it will be A only. Similarly, if I complete this, taking B, not taking B, empty, taking C, BC, not taking C, B only, taking C, C, not taking C, empty. Right? So here you can see all these are substrings, sorry, subsequences, right? All these are subsequences, right? ABC, AB, AC. And by what call, that is take it or not take it. Now in this question, why this is related to robbers, if you can see, okay, let me copy this. Here also we are basically calculating a subsequences. See, here if I simply add it, it will be ABC, right? Here if I am adding it, it will be ABC, AB. But you can see here if I am taking it, it will be 2 plus 7 plus 9. Can I write it like this? Right, 279. So basically, if ABC I represent like 279, basically I will find a sum. Here I will get 279, 2 plus 7 plus 9. Here I will get a sum of 27. Then here I will get a sum of 29. Then I will get 2 only, right? So this is quite of subsequences, but here is one condition, that you need to find the subsequences. Basically same function, you need to find subsequences but with non-adjacent values. Non-adjacent values. Okay, I don't need to add any adjacent value. I need to find subsequences with non-adjacent value. Remember, again, non-adjacent values. I can't add it, right? So basically our goal was like, since A, then call of B, then C, right? First call, either you can take A or B, A, A or not A. If you can take B or not B, if you can take C or not C. But here what we will do, we will put a call of A, then we will put a call of C, and then we will put a call of next call. We won't call it for B, right? So how we can solve this question? So let's see a quick pseudo code of it. So what I will do, I will take this array, right? And I will mention it here. I will remove all these things, this stuff. Okay. So let me put the indexes here. So we have 0, 1, 1, 2, 3, and 4, right? And what I will do, I will call my function, right? That is, suppose, house robber. So I am putting hrob, and I will call this function with the last value, right? So I will call this function with the last value. Suppose I will pass the nums, that is nums array, and I will call with the last value first. So can I say my n minus 1? And what is n here? N is nums dot length. Okay. So yeah, be with me. I will give you a complete answer how this is working. So basically my function hrop, what it will do, it has two values, nums and one I. Okay. And what I will do, I will say if I am taking, okay, how I will take it, I will basically take that character. So I will take nums of I, basically I will take it and I will call the next function, but not the adjacent. Okay. So I will call here my next function, that is hrop, but again remember not the adjacent. So I will call nums and I minus 2, right? That's a take if I am taking this one. So what I am saying, basically I started with 1, right? And I am taking, let's take 1, but now what I will take, I will take the next call, right? I will take 9 then, right? So I'm calling this function again with taking a 9, right? So I am calling this function by taking this 9. Now if I'm not taking it, right, that means I need to leave it. So if you are not taking it, that means you can take this one, right? That means you can take the adjacent now because you are not taking anyone. What I will do, I will take not take, and my not take will be, you are not taking it, 0 plus a rob and nums with I minus 1, right? And now what I will do, I will simply say whichever giving me the maximum result. So see, function calling, I am betting on this that this will be my maximum, right? Next, so I am taking this one. If I am not taking this one, right, so I will take this one. I am betting this will be my maximum, right? So either this path, okay, will be maximum or this path will be maximum. So what I will do, I will simply say return the method.max of take and not take, whichever path is giving me the best result. Okay, basically this I will do. And see, basically it will call whenever my I is getting less than 0, what I will do, I will return 0, right? So when I am returning 0, it will basically fill the 0. And suppose you reached here only, then what I will do, I will say if I am returning here, if I will say if I is equals to 0, I will return the value, basically that is nums of I, right? So basically this is the function, how it will run. See, I am at 1, and what I am saying, I am calling with the last one. So I am at 1 and I am saying 1 plus 1 plus. So I am calling this function, right? I am calling at 9. So if I execute this one first, so how it will execute? It will say 9 plus and again one function call from this one. But whenever I will come here, it will say I is equals to 0. So return nums of I. So I will return 2 here, right? And this will be 9 plus 2, right? So that will be 9 plus 2. That will be, I guess, 11. Okay. Now here it will be 11, but I have not added it. That's a take one. If I am taking this one, let's check out the result of not take. So what will be the result of not take? That is you are taking 3 and then you are taking 3. If I am executing this one, you will call 7, right? So you will call this function and again that's a function call, right? So what you will do, you will call the next one, the previous of it, and you are getting I less than 0. So you will get here 0, right? Okay. And like here you called it from 7, right? And here you are getting 0. So you will simply add 0, 7 plus 0, it will be 7. Then 7 plus 3, it will be 10. So you are getting 10 as the result. Now in 10 and 11, because in the last function, which is maximum, 10 and 11, 11 is maximum. So you will return 11 to 1. Basically that, so you choose here 1, either this path maximum or this path maximum. From 1 and 3, which path is maximum? 11. So you will simply put 11 and the result will be 1 plus 11, that is 12. Okay. So yeah, this is one of the method. Now here again we need to, there will be multiple function calls. So what I will do, I will add a DP here. So basically I will store the values. So instead of directly returning it, I will simply store in DP of I, right? And I will return DPI. And wherever, like if I am getting a dp of I here, and I will say if it is not equals to undefined, that means it is defined. What I will do, I will return dp of I. So I will return dp of I here, like this one, right? So this is one of the approach that you can apply. Okay, again, basically here what we are doing, we are simply calling from this function 0, and we are finding 0 or 1 which is maximum. Suppose this one or this one, right? In the last function call, we are calling from this one, and we are again checking which path is maximum. So both are same, both are following the recursion, right? So both are same, don't worry about it. Okay, now there is one more approach, that is tabulation method, right? So let's understand the tabulation method as well. So approach 3 is the bottom up approach with which using tabulation. So what I will do, let me quickly copy this one. So we'll copy this one, paste it here, and let's see what is this tabulation and how it works. Basically, see, I am anyhow storing, I am taking one array to storing the maximum values so far. In the recursion, what I am doing, I'm storing the maximum values in DP, right? So can't I do basic simply using one array? Can't I do it like this? So what I will do, this will be my DP, right? And what I will do, I will simply write 0, 1, then 2, then 3, then 4. Okay. And what I will do, I will start from this one. So here I will first put one value 2. Okay. And for this value, see what is the approach. For this value, I will say, okay, if I am taking this one, if I am taking 7, it will be 7. If I will get 7, right? If I am taking 7, if I am not taking it, so which is so far maximum? Which is so far maximum? That is 2, right? So far, this is our best result. So which is so far maximum? That is 2, right? So which is maximum between these two? If you are taking 7, if you are not taking, that means so far maximum is 2. So if the good chances, take it, right? So if I take it, I will be 7, right? Then I will call to the next one, right? I will call to the next one. I will call it here, right? And again, same result. If you are taking 9 and you will take with this one, right? So far maximum was 2. So 9 plus 2, you will take, you will get 11, right? So if you take, you will get 11. If you are not taking it, so far maximum is 7. If you are taking it, 9, so 9 with the last value, right? Not a non-adjacent value. So 9 plus 2 will be 11. If you are not taking it, so far maximum will be 7. So which is maximum? 11. So you will take it. You will take 9, and the result will be 11 here. Similarly, when I call with 3, when I call for this index, right? So if you are taking 3, and how you can take it 3 with the 7 value? So 7 plus 3, it will be 10. Okay, so if you are taking it, you are getting a 10 result. If you are not taking it, so far maximum is 11. So far maximum is 11. So which is maximum? So far maximum, that is 11, right? We are getting already 11. Why should I take it? So I will go with the not take, and so far maximum will be 11 only. Okay. Now I will call for this one. Okay. Fourth one, right? I will take it. If I am taking it, how I will take it? I will take it to 11 plus 1. So 11 plus 1 will be 12. If I am not taking it, so far the best result I am getting 11, right? So should I take it or not take it? Take it, right? You are getting a 12. So 12 will be my result, and the last answer will be my answer, right? Last point, you can say, will be my answer, right? If you want, let's take one more example to understand it much more better how this is working. Basically, we are using again the same DP. So let me take a good example here. Let's see, let me create an array. So let's understand with this example. What I will do, I will first write here like the first element itself, because that will be the maximum. So far I am taking this one. Now next count will be like, next count it will be like, I have only 2, right? And so far maximum is 1. There is no other element here, so I will take it, but there is no, so I will go with the 2. And so far maximum is 1. So which is maximum? 2 only, so I will take 2, right? Then I will take 9, and 9 with the last one, because like this is how you will select it. So I will take 9. Okay, if I am taking 9, so 9 plus 1 will give me 10. If I'm not taking it, what is so far maximum? That is 2 only, right? So should I take it or not take it? Take it. So your DP will be 10. Okay. Now here, if you are taking it, right, so you will take 3 plus 2 because the last one 3 plus 2. So 3, let me remove all this. If you are taking, it will be 3 plus 2, 5 as a good result. If you are not taking it, so far maximum is 10. So should you take it or not take it? Not take it. Go with the last. So I'm going with the last one, 10. Okay. Now here for 7, if you are taking it, right, for 7, so if you take it, you will take 10, right? So basically 9 plus 1, 10, and 10 plus 7. So yes, if you take it, 7 plus and so far 10, you will get 17 as a result. If you are not taking it, the result is 10 so far maximum. So you are getting 10, which is maximum, 17 or 10? 17. So you will take it. The result will be 17, right? Same case for 8, right? I will call 8 with a 10, right? So 8 plus 10 will be 18, right? So 8 plus 10 will gives you 18, right? And so far maximum you are getting 17. So should you take it or not take it? Take it, right? So you will get 18, right? Then the next call will be 9 with the last one, 9 plus 17. What it will be result? The result will be 26, right? 26 you are getting here. If you are not taking it, you are getting only 18. So yes, you will take it, 26. Now again one result with the 9, right? So you will take 18 and 9. What you will get as a result? You will get 27, right? And so far maximum you are getting 26. So yes, you will take it, and you will take, so that the result will become 27. Now you are getting 5. If you are taking 5, so 5 plus 26 will be 31, right? If you are not taking it, the so far result will be 27. So which is maximum? That is 31. So the answer will be here 31 so far maximum, right? And yes, the answer will be 31, right? So we have solved this kind of problem. Remember, right? There was one problem where we have different numbers and we always pick the best of these numbers, right? Again, we will add it and move for the best of these two numbers. Similarly, we are solving this question. Okay. So this is how you can solve this problem, right? Tabulation method. What will be the code of it? Let me show you. It will be exactly same as what you do in your there in recursion. Okay. So let's see. So now check the pseudocode of it. So basically what you will do, you have one rob function, right, with the nums, right? This is the function. Let me remove this one, all this stuff. What you will do, you will simply run a for loop, okay? That will start from I equals to 1. Remember, I am always starting from I equals to 1 because that is the same element will be like already there. So can I write it here only, that I will suppose start with some dp. So I will start with the dp, and dp of 0 will always be nums of 0, right? Starting with it. And what I will do, I will start from 1 and I will go till n less than equals to n, where n is the nums dot length. Not equals to n, that will be lesser than n only. And I will do I plus plus. Now what, inside this for loop, what I will do, right? So I will take, first of all, call of take, if I am taking it or not taking it, right? So I will take it, and it will be nums of I plus dp of I minus 2, right? But if you see, I am starting from 1, so 1 minus 2 will be I minus 1, dp of minus 1, and that it will give me undefined. So what I will do, I can simply say that run this only when if I is greater than 1. Then what I will do, I will simply say take plus equals to dp of I minus 2, right? And suppose if I'm not taking it, right? So if I am not taking it, so what I will do, I will say 0 plus dp of I minus 1 so far maximum. Remember, so far maximum we are getting 2 only. So what I will do, I will say my dp of I will be method dot max of taking, if I am taking it or if I am not taking it, right? So if I am taking it and not taking it, it will be like it will give me the maximum. And in the last, what I will do, in the last, I will return dp of nums dot length minus 1. You can also do a bit of change. Basically, see, and you can directly start from 2, so you don't need to write this condition. You can directly write take plus take equals to nums of I dp I minus 2 if you are starting from 2. Only this thing will be changed here. Dp of 0, you need to say that method dot max of dp of 0 and dp of 1, right? So that is also one way to do it, right? If you want, I can give a quick demo of this. So basically what we will do, we will simply remove this one, right? And I will remove this one, and I will remove this one, right? What I will do, I will say nums of I dp of I minus 2, right? And I will start from 2, right? So this will work exactly the same. And here I will say my dp of 0 will be dp of 0 only, that is nums of 0. But see, since I am starting from 2, I should have dp of 1 as well. So dp of 1 will be method dot max of nums of 0 and nums of 1, right? So whichever the max, that will be dp of 1, and I can simply start by taking this. Okay, so just a tweak in the same approach. Now see, let's discuss about the time and space complexity of all the approaches that we have discussed so far, right? So we have discussed that this was our approach 1, okay, where I'm calling functions again and again, where the pseudocode was. So exactly like this was the pseudocode. If I say yes, this was the pseudocode, right? So I'm using dp here. So basically dp will reduce the same number of function calls, right? So the time complexity of this approach will be big O of n, right? Space complexity will be big O of n for using dp plus big O of n of using that recursion stack, right? Recursion stack will be there, right? So for stack, so it will be big of n, big of n, big of 2n, right? And big of 2n, this will be the time complexity. If you are ignoring 2, then it will become big of n, right? Because order of n, basically. So yes, it will be an order of n. But remember that we are using two storage. One is dp and one is stack, right? Same here, right? If I talk about here, what will the time complexity? In both the case, we are using recursion only. So time complexity will be big O of n because we are using dp, right? So dp will reduce the number of function calls, and space complexity again big O of n plus for dp and n for stack. So it will be 2n. So it will become big O of 2n, that is similar to big O of n, ignoring the constants. Right. Now let's talk about approach 3. Right here we are using dp. So the time complexity here, I'm starting a loop from 1 to n. So time complexity will be big O of n. We are using dp, so the space complexity will be big O of n. And there will be no further recursion call stack, right? We are not using recursion, so no call stack. It will be big O of n. So time complexity big O of n, space complexity big O of n, right? And now let's see, can we reduce this space complexity as well, right? We have so far decreased from 2n to n, but can we reduce this space complexity? So see in here the results. This result 12 was determined by the maximum of these two, right? Basically, I got the maximum 11 and I just add 1 and I got this result, right? And how 11 was determined? So basically 11 was determined by taking, if you are taking 3 plus 7, you are getting 10, right? So you are calculating this, you are taking this 11 into consideration, and 7. These two values will be useful because why? 3 plus 7 will give you 10 and 9 plus 2 will give you 11, right? So basically you are taking this 11 as a value and 3 plus 7 you are getting 10. So can I say for this 11 you are using the last two values 7 and 11. For 12 you are using 11 and 11, which is maximum, right? Similarly here you can check this one here, right? 31, how 31 is basically determined by 5 plus 26, 5 plus 26 and 27, right? So 5 plus 26 and 27, right? You are comparing between these two. How 27 calculated? That is 9 plus 18 and the last 26. So you are calculating 18 and 26. You want 18 and 26. So on each iteration, if I am talking about this I, these two values will be required. These two values will be required. If I am talking about this I, these two values will be required. These two values will be required. Rest of the i's, no. Right? Rest of the values of DP, no, right? So for each iteration you want only these two values, right? So why we are creating a complete space of n, right? Why we can't use two or three variables, right? So what I will do, I will use only two variables and simply remove this from this stack. So see, you just need to calculate any value 13 by the two values. So I will take suppose one variable as last one and the second value is second last. So you can say last one and last two, right? So instead of dp0, right, I will say that this will be my last one, right? Or I can, let me put it in like in a copy so that I won't disturb with my flow. So yes, I will say that this is my last one, right? And I will simply remove dp0, right? And here wherever I am using dp of 0, so here if I'm starting from 1, 1 minus 1 will give me dp of 0, right? So I will use last one here, okay, last one here. Here I'm using dp of I minus 2. So what I will do, I will create one more variable last 2 and let's initialize with 0 because for 1 it will be 0, right? You won't come here. So I will initialize with 0. And what you will do, you will update this with last one, right? So you are getting dp of I, right? How you will update it? You will simply update with the last one, but before last one you will make a change here that your last two will become last one, right? And last one will be this value. So you are using only two values here, right? And in the last, what you will return? You will return the last one that you got. Okay. So basically here you have started last one with nums of 0, last two with 0, right? Here you have added last one, dp of I minus 1, right? I minus 2 will be 0. So this will be your last two, right? Let me put with the white pen only. This will be my last two and last two will become last one before, because here I am update my last one. Last one will be dot max of take and not take. I will update with last one and I will put last one. So last one value will going to be changed, and before going to be changed, I will update the last two equals to last one, right? So yeah, by doing this, the time complexity will decrease from big O of n to big O of 1. Right, the time complexity will become big O of 1 because you are taking only two variables. So yes, these were the total, I will say 1, 2, 3, 4 approaches if you are considering this by taking two variables, right? We have discussed. In the next video, I will give you a code implementation of all these approaches. So see you in the next video where we will discuss about the code implementation, and then in the next video we will do a dry run. Okay, so be with me till dry run, you will get the things.